What's good, Internet? So today we're going to talk about Daily Coding Problems. Daily Coding Problems is a website which provides coding challenges for you to work on and solve. Today we'll be getting started with the first one that they offer, which we can take a look at right now. This is the first problem. It was asked by Google, and it reads, "Good morning, here's your coding interview problem for today." This problem was recently asked by Google. Given a list of numbers and a number k, return whether any two numbers from the list add up to k. For example, given 10, 15, 3, 7, and a k of 17, return true since 10 plus 7 is 17. Bonus points, can you do this in a single pass? So this is a really fun problem, and it's one that gets to show us a little bit about complexity in programs, and it gives us a chance to practice test-driven development. I'll create a new folder named Python because we're going to start off with a Python solution, which is usually one of the languages that people start off with in these types of pseudocode style challenges. We'll go into the Python directory. We'll create an init file so that we can run our tests easily and simply using that. And we'll start off and we'll say test solution.py. We want this to use user bin and Python 3 to make sure we get whatever version of Python 3 is currently installed in our environment. In my case, that's going to be installed via Homebrew, which you can find out how to install via the internet. We'll start off and we'll say that define a new function, and we'll call it test solution. It's going to take no arguments. We're going to say that the list in is equal to 10, 15, 3, and 7. And then we're going to say that our expected output, which is our k value, is going to be 17. The benefit of this is that now we can say our result is equal to the function solution, and we're going to provide it our list in, and then we'll assert that our result is equal to our expected output. Now the first problem that you may notice here is we haven't yet defined a solution function, nor have we put it in this or any other file. As a result, we'll go back up to the top of the file, and we'll say from.solution import solution, which is saying from the file solution within this module, import the function solution. You'll notice that my editor is giving us a little bit of a warning here on the left-hand side saying cannot find module named python.solution. You can see that right along the bottom down here. That's fine, we'll get to that in just a second. We'll save this and close it. Now if we run PyTest to validate that this does not yet work, we can run this and we notice module not found error, no module named python.solution. So let's get started and fix this. We'll create a new file called solution.py. We'll start off with our Python shebang in Python 3, commonly referred to these days as modern Python. And we'll start off with the first solution that usually comes to people's mind. Now, some people refer to this as a naive solution. Some people refer to it as O to the n squared. Some people refer to it as a brute force solution. I like to think of it as a good starting point though, regardless. We'll start off and we'll say define a solution. Now, remember that we do have to take a list in, so we'll say list in. And if you use modern Python, you may be interested in using type hints. This can be really helpful if you're trying to understand or communicate to other programmers what type of function arguments your functions are going to take in return. In our case, we'll add some type annotations. So we'll say from typing, import list. And we'll say that the input list is a list of integers. And this is going to return a Boolean value. You'll notice again that my editor is complaining about this because of saving it. Unexpected end of file while parsing. That's because we haven't given it a function definition yet. So with this, we can say for number 1 in list in, for number 2 in list in. And essentially what we're going to do is we're going to try to calculate those sums by looping through each of the lists once and checking, does the first number and the second number give us the expected value that we want. One thing that we do actually have wrong here is, how do we do that comparison if we don't actually know what the number we're expecting is? So in this case, we're going to say list in is a list of integers, and then our expected, or this would be our k value, which is also an integer, is going to be our second argument. We'll open up a split using our test solution as our right-hand side, and we will make this modification over here that our expected output should go into our function as well. So essentially what we're going to be doing is, for each number in our list, we're then going to check, do any of the other numbers in that list, when added together, give us the expected result that we would like. In this case, we're going to say that this is potential k, and this is equal to the number 1 plus the number 2. Pretty straightforward there. And we'll say if potential k is equal to the expected value, return true. And true in Python is capitalized. Now this is pretty straightforward. We're just going to loop through every single number. So in this case, first the number 10 is going to be number 1. Then we're going to loop through it again. Is 10 plus 10 equal to 17? Then we'll do the second number, is 10 plus 15 equal to 17? And we'll repeat this until we've gone through the list twice. If we've gone through the list twice and we still haven't found our value, then we need to return our false value, saying that no, none of the values in the list when added together are going to give us the expected result that we would like, or the desired result. So we'll save this. We can close that, and we can close this, and we can run PyTest and see what happens. At this point, we do see that expected output is not defined. That is an issue with the naming of the variable that I put in. And we'll do a vertical split of our test. And that seems to be where the issue is. So you'll notice on the 11th line that PUT at the end of out, we're going to just cut that out, save it, and then we can close it and rerun things. And at this point, we should see assert true is equal to 17. You'll notice that this is where the problem starts to come in. We didn't actually follow what the challenge was really asking for. If we go back up to the README, you'll notice that this says, given an array and given a value, return true or false if the numbers within that list add up to or create a sum that is equal to the value of k. So our expected result, by definition, should be a Boolean. We'll fix that in our test quickly. So this is going to be our k value, and our expected output is actually going to be true. Now if we save this, we need to also actually fix that we don't want to pass in our expected out, we want to pass in k. And now with that saved, we can clear our terminal, run PyTest, and we see that it passes. So this is great. Now, one of the things that may frustrate you, I know that it's frustrated some people, is if you ran Python 3 solution, nothing happens. And that can be kind of frustrating depending on your desires or interests in terms of being able to test and modify your solution and needing to install additional software. In this case, not everyone is going to have PyTest, and that's going to be difficult for you to use if you're using a third-party service or you're doing coding in the web browser. As a result, let's make a few little modifications to our solution so that we can actually use this anywhere that we go. And to do this, we're going to use a module within the standard library known as doctest. So in this case, what we're going to say is we're going to jump down to the bottom. We're going to skip 2 lines and say if the name of the file as it's being executed is equal to main, dunder main, then we want to execute our doc tests. So we can say from doctest import testmod. And what this is saying, from the doctest module, we want to import the function named testmod. Testmod is short for test module, which is going to allow us to run tests against the document strings associated with the functions in this. We'll need to add that in just a second, but first we can just add testmod. Save that, and now if we run Python 3 solution, again, nothing happens, and that has to do with the fact that, well, that's just how it works. If you actually wanted to see the output, you need to pass in the TAC-v flag to the script, which prints out a detailed log message of what it's trying in a summary. And in this case, 2 items, no tests, so the tests technically pass. Let's add some actual tests though. So inside of our solution, this is where we're going to add it. If you've ever worked with the Python REPL, this is going to use that same type of syntax. So we'll start off with 3 quotes. We'll say that this returns true or false if the sum of any 2 numbers in the list in variable add up to variable results in the expected variable's value. Now, this isn't a test, obviously. This is just giving the programmers in the future something that they can look at to understand what is this actually about. To add it, we can start off with the triple chevrons, and we will say solution. First thing we want to pass in is our list. So we can say this is going to be the values 10, 15, 3, 7. Second argument is going to be the expected value, or our k value, which is going to be 17. And if we run this, we should see a true result. And that's really about all there is to it in terms of setting this up. So we can save this again, close it, and now if we run Python 3 solution TAC-v, you'll see that it's trying to run the solution. It's expecting the value true, and it did successfully get this. This is a simple way that we can do unit testing or something like unit testing with the standard library without all of the hassle of boilerplate unit test code, or using something like mock test where you may have to, or PyTest where you may have to include an init file to create a full module. Now, at the beginning I did say that this was something which is a bit naive, and one of the problems that you may be aware of is O to the n complexity. Big O syntax is stating overall complexity of a function, and in this case we're doing O to the n squared. What does that mean? In this case, you'll notice that we have a list of length n. It could be any number that we want. It could be 1 item long, it could be 10. In this case, in our little solution doc test, it's a length 4. The thing is, when we run our function, in our case solution, you can essentially think of the O as the name of the function. It's taking in something and it's outputting something. N is the actual description of how complex is it. In this case, we have a list, it's n long. We have to run through that entire list or part of the list at least once. The problem is though that we're running through it a second time, trying to do that addition, that summation to see do any of these numbers actually add up. And this is what's giving us the squared, because if we assume that that length of the list is n, we're getting n, we're multiplying it by n again, and that's going to give us O to the n squared. This is where we can start to implement some of the concepts of algorithms that we may or may not be aware of. And hopefully I can introduce you to a new solution that you may not be familiar with yet. So we're going to delete this quickly. And we're going to say that, okay, how can we implement this concept a little bit better? We're trying to understand the sum value and see if we happen to have that already or have seen whatever would have given us that sum. And this is where being a little bit creative can come in handy. In this case, what is addition? Addition is taking one number and putting another number with it in addition to it to give us a final result. In our case, that expected or desired result is being given to us. If you think about algebra, you can essentially be saying that k, which is the value, is whatever the number is plus some other number. And to do this, we can say, what numbers have we already seen? And in this case, we're interested in seeing what numbers have we seen, and if we've seen them before, potentially it's something that, well, if we add it together, we can get the result we want. So let's take a look what this looks like. We can start off and say that the numbers that we've seen are going to be stored in a set, and we can say seen is equal to a new set. If you're not familiar with sets, they're essentially a dictionary object with no value associated with the key. The reason that we like sets and the reason that sets are so important from a programming perspective, you may be familiar with them under a different name like hash set, is because a set can contain the same number one time or the same key value one time, no matter how many times you want to do it. Because it's a hashable object though, that means to check if a number or a key is within that container, we don't have to actually go back and say, okay, is it the first object? Is it the second object? Is it the third object? We can simply say, okay, what's the hash of this object? Okay, it's this. Do a quick check. Does this have that hash? It does or it does not. And we avoid some of that additional time penalty that we would get searching through a list otherwise. So to leverage this, we have to go through our list at least once. There's no other way around it. So we'll say for number in list in. And at this point, we want to say, no matter what, we want to say that we've seen this number. So we'll add the number into our list of seen numbers. Before that, though, we need to do our little comparisons. Addition is the opposite of subtraction. So what we can say is, what is the difference instead? The difference is going to be equal to our expected value or our target number. Expected isn't really making a lot of sense here anymore. So what we're going to say is we're going to say target number or desired number, depending on which one you feel is more clear. So we'll replace this with target number and save that. So the difference is equal to our target number minus whatever number we're currently looking at in the list. This is going to give us the difference between that target number and the current number that we're looking at. So in the case of this doc test up here, first time through, we're going to get 17 minus 10 is equal to 7. We're then going to check, have we seen the number 7 anytime before? If we have, then we know, okay, well, we've already seen that number before. That number with this number would have given us the result that we're looking for. So we can say that, yes, this is actually going to give us the sum without actually having to do that sum. So we'll say if the difference is inside of our seen variable, return true. And that's really all there is to it. We can then return false, saying that we haven't seen it if it's not in that loop. You'll notice at the bottom that this is complaining that we need type annotations for scene. And you may be wondering why. When we look at this, the editor knows that we're using type hinting because we're using it in the beginning function declaration. The problem though is we're declaring set here, but we're not actually telling the system anything about it, so it can't do any safety checks to tell what that is. We can say set, jump back to that equals, and we can say that this is a set of integer values. If we save this, that fixes that issue that we were seeing in the left-hand gutter. Save the file. We can start off and say Python 3, solution.py, test it. That worked, and we can also run PyTest. And with that, that gives us our solution in Python in the most effective way possible. If you wanted to do additional comparisons, you certainly could using the test it or time it module. The one thing that's kind of interesting in this case is this is a solution which is pretty cross-compatible no matter which language you're looking at. In this case, we've been using Python, but if we wanted to, we could go back and say, let's take a look at what this would look like in Ruby. We can open up a new file called main.rb, and we can say user bin env ruby. If you're not familiar with this type of a shebang, if you're used to bin Ruby or something like that, this is the version that I found for shebangs to be most effective in terms of portability, specifically when you're on a developer machine that may not have all of the permissions able to update the system versions of certain types of binaries. In this case, we're referring to Ruby. And in my case, that's installed via Homebrew, which is going to put it in a non-standard location. Now, sets, unlike in Python, are something which are not included in the default syntax out of the box. So we do actually have to require the set module. The second thing that we want to do is we want to require Minitest so that we can set up our testing infrastructure and run tests associated with this problem. To create a Minitest test, you can say class test solution, and we're going to inherit from Minitest's test class. We can say define a new function named test solution. We can say that our list in is going to be 10, 15, 3, and 7, just like we did before, and our k value is going to be 17. The result is solution, and we need to pass in our list in as well as the k value that we're looking for. Now, Minitest is a little bit different in terms of how we do assertions about what is true or false or what the final result is. Unlike Python and PyTest, where you can just simply say assert, we have to be a little bit more descriptive with Ruby. So we say assert underscore equal, and we're looking to say that the result is equal to the value true. Note again, Ruby doesn't use uppercase syntax for Boolean values like true and false, so we do need to make sure that that is lowercase. Then we can end our function like so, write that, and if we started off, we could say Ruby main, and you'll notice that we get an error. Test solution tries to test solution, but it's calling an undefined method. If we fix that quickly, we can say main.rb, and we'll define a new function called solution, and it's going to take two different arguments. First, our list in, and secondly, our k value. And I like to put the n as soon as I begin a function. That way I don't forget where it is in terms of the hierarchy of the function, especially if you have a lot of nesting. In this case, it's not going to be a big issue if you want to hold off on that for later. I prefer to do it at the beginning though, just to make sure I don't mess up where it goes. And here we'll say, similar to we did before, we're looking to define a new set. Set, because it is a class within the set module, is going to be an uppercase value. we say scene. And to loop over something in Ruby, instead of saying for item in list, we go list_in.each, do, and then this is going to be our number. And this is going to give us that for loop type syntax where we can loop over every single item in the list, check if we've seen it, and find out what that difference is. So the first thing we need to do is our difference is equal to our k value minus the number. This is going to give us how far is it from the current number that we have to that k value. And then we're going to say if the set scene includes the difference, return true. Ruby has a little bit more heavy-handed syntax in terms of beginning and ending of blocks, so we do have to make sure to put that end there after the if statement. We can then add the number to our set of scene items. And at this point, we have a mostly working solution. It's going to correctly return true if we've seen the item. We need to make sure to, after our for loop though, return false in the off case that maybe we didn't find the value we were looking for. We can actually add a test for that too. If we copy this, we can go test solution does not exist, and we'll remove the 7, and we'll expect a false value back. We can save this and run Ruby main, and we see 2 dots. If you're familiar with Minitest, or in the same way that PyTest does this as well, you'll know that periods are signaling that they ran and that they were successful. Normally you would see an exclamation mark or other type of error message associated with failures. And with that, we have 2 working solutions, one in Ruby, one in Python, as well as fully tested code. Now, the tests could be a little bit better, a little bit more thorough, specifically in terms of edge cases. What happens if somebody gives us a string? What happens if we have floating point numbers? Are there any concerns about those? Those are items that we're not going to test today, but if that's something of interest, please leave a comment below, and we'll do that in future videos. Thank you everyone very much for your time, and hope you guys have a great day. Thanks.